So hey guys, welcome back to Civil Learning Online YouTube channel, and today in this video I am going to discuss about relaxation method. So first of all we will begin about the characteristics which is required for the equation to be solved by using the relaxation method, and after that we will proceed with the process. So if you haven't subscribed this channel, then do subscribe the channel, and without any further delay let's get started. So first thing we need to consider while solving any kind of numerical by using relaxation method, we have to look for the diagonal dominance property. So first of all, when we proceed through the equations, we are provided three equations, and in uppermost or topmost equation the coefficient of x or the constant of x is greatest of the sum of the constants of y and z. Similarly, in second equation the constant of y is greater than the sum of the coefficient of x and z. Similarly, the constant of z is greater than the sum of the constants of x and y in the final third equation. If not, then we have to arrange the equation in order, in such a order that in first equation the constant of x will be greater than the sum of the constants of y and z. Similarly, in the second equation the constants of y must be greater than the sum of the constant of x and z. Similar also in third equation the constant of z must be greater than the sum of x and y in order to in order that the diagonal dominance property would establish. Now we will proceed further. So as usual, our solution begins by writing solution. Now our first step is to write down the residual form of the given equation. So I am going to write a line here: the residual form of given equations are, let the equation residuals be represented by r1 for equation 1. So r1 will be equals to 205, and bring all the terms carrying variable to other side of equals to. So here this is plus x, so plus 10x, so it will get minus 10x minus, sorry, this is minus 2y, so plus 2y, and this is minus 3z means plus 3z. Similarly, for r2 we have 154, and minus 2x means plus 2x minus 10y, and plus 2z means, sorry, minus 2z will get plus 2z. For r3 we will have 120, and this is minus 2x means plus 2x minus y means plus y, and plus 10z means minus 10z. Now we have successfully written the given equation into residual forms. Now we will draw a table, and in table we will write down the coefficient so that we will use them to find the residuals and increments. So we will write residuals and increments. So we need to draw 3 columns and 3 rows. So first let us draw 3 columns, second and third column, and this is first row, second row, and third row. Now for residuals we have r1, r2, r3. Similarly, we will represent the increment with delta, and increment in x as delta x, increment in y as delta y, and increment in z as delta z. Now what we will do, we will write down the coefficients of, or the constants of the variable, horizontal variables, in vertical form. So here it is minus 10x, means we will write here minus 10, and this is, we will write horizontally to vertically. So this is plus 2, so plus 2, and plus 3, plus 3, plus 2z plus 2x means 2, minus 10y means minus 10 and 2 means 2. Are you getting what I am doing here? We are writing rows to column, means horizontal to vertical. So we have plus 2y, so 2 plus y means plus 1 and minus z. Now proceed further, we will do the first approximation now. So our first approximation is for first approximation, what we will do, we will proceed taking the value of x, y and z as 0. How? See here, put x equals to 0, y equals to 0 and z equals to 0 in these three equations, in residual equations. So from here on putting x equals to 0, y equals to 0, z equals to 0, we will get the value of r1 from equation 1, and value of r1 will be 205, because all the other terms will get 0, because on multiplying any number with 0 they get converted to 0. Now value of r2 will be 154 and value of r3 will be 120. Now we have, as we have got the value of r1, r2 and r3, we will look for the greatest value among these three values. So greatest among these three is r1, that is 205. So we will write here maximum is r1. So for now we have got the value that is maximum r1, maximum is r1. After that we will look in the r1 column for the value which is highest among the value of del x, del y, del z. So in column r1 maximum value is 10, and corresponding to we will, and while looking in the column, we will not consider the positive or negative sign, we will consider negative sign also as positive. I hope you are getting my points. What I said, we will not look for the sign whether it is negative or positive, we will look for the greatest number. So here it is minus 10, so we will consider it as 10 while looking out for the greatest value. So we have maximum r1, and in r1 column maximum value is 10, so we will, and corresponding to 10 is del x, so we will write here del x equals to, and r1 is 205 positive, so divide it by 10, we will take positive sign. So 205 will get divided by 10, we will get 20.5, that is our del x. Now let's do second approximation. So we have second approximation. So for second approximation, what we will do, we will write down r1, r2 and r3, and the value of r1, r2 and r3 are 205, 154 and 120. Now if we have a quick look to our equation, what we come to know, we have got the value of r1, r2 and r3, we have increment in x. So this time we will use the portion which contain x from the residual equation. So we will neglect y and z. We have minus 10x, so we will write here minus 10, and in place of x we will use the increment value, that is 20.5. okay, now we have plus 2x, so plus 2 times del x value is 20.5. again we have plus 2x means 20.5. Now on solving this, we will get the second approximation value, that is 0, 195 and 161. Now we have, after that, once again we have to find the increment. We will look for the maximum value of these three. So maximum is r2, so we will write here maximum is r2, and for r2 we will again look for the maximum value in the column of r2. Maximum is r2, in maximum r2 it is 10, so 10 is corresponding to del y, so we will write here del y equals to maximum 195 divided by this value, that is 10. We will not take the negative sign, so 10 divided by 10 we will get 19.5. now time for third approximation. We will proceed like we have done till now. Now time for third approximation. So we have third, I hope this is visible to you, third approximation. So for third approximation, we will again write down R1 equals to, now use the value which we have calculated, R2 and R3. We have the value 0, 195. From here we are using the value of R1, R2 and R3 what we have got in second approximation. We are using those value in third approximation. We are using the value of second approximation R1, R2, R3 value of second approximation in third approximation, that is 195 and 161. Now in second approximation we got del y, so we will use the portion of the equation which consists of y and we will neglect x and z, that is plus 2 times, and y is 19.5. similarly minus 10 times y is 19.5 and plus y is 19.5. So on solving this we will get the third approximation value, that is 39,180.5. again maximum is 180.5, so we will write here maximum is R3 and corresponding to R3 that is 10 is maximum and corresponding to 10 is del z, so del z equals to 180.5 divided by 10 and we got 18.05. Now time for fourth approximation. For fourth approximation we will do R1, R2 and R3, and R1 equals to 39,180.5 and plus 3 times 18.05 equals to 93.15 plus 2 times 18.05 36.10 minus 10 times 18.05 we will get 0. Now again maximum is this, so we will write here maximum is R1, so R1 in R1 we have del x, so del x equals to 93.15 divided by 10 and we will get 9.315. Again for fifth approximation we have to do the approximation until we will start getting the value of this increment near to 0 or equal to 0. So for fifth approximation we have R1 equals to we will use the value R2 and R3 equals to 93.15 36.10 and 0. So we will again use the we have got del x, so this is minus 10 times x is 9.315, so this gets 0 plus 2x plus 2 times x means del x, so 9.315 and plus 2x is 9.315. so on solving this we will get the value of fifth approximation, that is 0 and 54.73 18.63. now maximum is R2, so maximum is R2, therefore in R2 we have del y equals to 54.73 divided by maximum value, that is 10, so we will get 5.47 3. Now time for sixth approximation. So we have sixth approximation. So for sixth approximation we have R1, R2, R3. Write down the value, that is 0, 54.73, 18.63, and we have Y. So Y is plus 2 times Y is 5.473 minus 10 times 5.473 Y plus Y is plus 5.473. So on solving this we will get the value, that is 10.946, and this gets 0, and from here we will have 24.103. again maximum is 24.103 in R3. So maximum is R3, and in R3 we have del Z equals to 24.103 divided by 10. So 10 we got 2.4103. Now proceed with the same steps for further approximation. Let's see, and we will need to stop when we get the least value of del Y or del X or del Z. So after doing sixth approximation successfully, we have reached seventh approximation. So in seventh approximation, what we have done, we have retained the value of R1, R2 and R3 of the sixth approximation. These are the value of sixth approximation, R1, R2, R3, and then we have substituted the value of that increment in the equation, leaving the other variables which we did not find the increment in sixth approximation. And further we have eighth approximation. So in eighth approximation we have written the value of R1, R2 and R3 of this seventh approximation, that is 18.17, 4.8206 and 0. Now we have got the increment in del X. So del X we have got this value and minus 10x. It was minus 10x in first equation. So in place of x we have reused the value of del X. So here it is, and then it was plus 2x. So plus 2 and x value is this. So on doing so, we have successfully done up to the approximation 14. We have used the value of R1 and R2 of the preceding approximation in each and every approximation, and on reaching the 14th approximation we have got the increment nearly close to 0, that is 0.0257. if you want more precise answer and you have sufficient some more spare time in exam, then you can do more approximation, but 14th up to 14th approximation it must be sufficient for any kind of numerical. I am saying this on the basis of the maximum number of questions which I have solved. For up to 14th approximation it will be sufficient. So now what is the further steps? So I am going to discuss that now. So once we have calculated the value of del X, del Y, del Z up to 14th approximation, we have to find the value of X. So value of X will be equals to summation all the value of del X, all the value of del X. Similarly Y will be equals to summation del Y, and Z will be equals to summation del Z. Means we are going to add up all increment value which we have calculated in the numerical. So on doing so, we have found the value as del X equals to 20.5 plus 9.315 plus 1.817 plus 0.303 plus 0.052. On doing so, we will get 31.987, which is approximately equals to 32. Similarly, del Y will be equals to 19.5 plus 5.473 plus 0.845 plus 0.150 plus 0.025 equals to 25.993 equals to, which is approximately equals to 26. Similarly, summation del Z means 18.05 plus 2.410 plus 0.448 plus 0.075. So on adding these we will get 20.98, which is approximately equals to 21. and we have now got the value of x, y and z, and this is the end of this numerical. See you in the next video. Till then, stay safe and take care of yourself, and do not forget to subscribe Civil Learning Online YouTube channel if you do not want to miss any updates.